Hello Year 10. Today we're going to be looking at similar triangles. Now these are going to be quite similar to what we were looking at with congruent triangles, except similar triangles are triangles that are the same shape but different size, and we'll see exactly what that means in a moment. I just want to recap congruence. Here's something that would make a pretty good exam question on congruent triangles. We're given two triangles here, ABD and ACD, and we're asked to prove that these two angles are equal. So I'm going to go about writing my proof. I'm going to start with something that we're given here, that AB is equal to AC. Now, something else I can identify that's equal is this side, AB, or AD, sorry. It's actually common to both triangles. And the last thing we've got is the angle down here in the bottom, which is also given to us as being the same. So therefore, we can say that these triangles ADB and ADC are congruent because they have the right angle, the hypotenuse, and one other side the same. And if these triangles are congruent, therefore that means that angle B has to be equal to angle C. Just a quick getting better at maths question for you guys. Sam tossed a coin 3 times. The coin has landed on tails 3 times in a row. He tosses the coin again. What is the probability of landing on tails in this 4th toss? I'd like you to pause the video for a moment and think about this question. Okay, hopefully you've had a go at answering it. I think the answer is 0.5. Because the probability of tossing a coin is always 50%. It doesn't matter what's happened before. Okay, now we're moving on to talk about similarity in triangles. Similar triangles are the same shape, but not necessarily the same size. So what that means is angles are equal between the two triangles, and the side lengths are in the same ratio. We'll see exactly what that means in a moment. And the way we write when two triangles are similar is we actually use these 3 vertical arrows. When we were doing congruence, we used the 3 horizontal arrows to say that the two triangles were exactly identical to each other. But when we're talking about similarity, we use 3 vertical lines. Alright, let's move on to looking at some tests for similarity. So the first one, and the simplest one, is finding a pair of equal angles. You only have to worry about 2 angles, because if 2 angles are equal, that means the third has to be equal as well. So we're only really concerned with finding 2. The next test for similarity is that 3 sides of each triangle are proportional to each other. So what that means is that when we take all the sides from our bigger triangle over here and make fractions with all the sides of our smaller triangle over here, so these 2 corresponding sides become 6/3. These 2 corresponding sides become 4/2. And these 2 corresponding sides become 2/1. All of these 3 ratios simplify to the same thing, and that's 2. That means that the ratio of all these sides is the same, and therefore these two triangles are similar. The third test is that we have two sides in proportion. So here we would have 4/2, these two sides, and 2/1, these two sides. Again, the ratio is 2. And then we have the angle between them being equal. That's given to us. That means that these two triangles are similar. Two pairs of sides in proportion and the angle in between them. The last one is the same as our RHS test in congruent triangles, but this time we're looking for the hypotenuse to be in proportion and one other side, and then the right angle obviously is the same. So let's put this into practice and try some proofs for ourselves. So looking at A, we have two angles here being 70 degrees, and we have another two angles here being 30 degrees. So that means that these two triangles are similar. And the reason is two angles. Okay, looking at the second pair of triangles here, we have this pair of sides, we have this pair of sides, and we have this pair of sides. So let me just write that all down. And we can see that all these ratios are the same, so that means that these two triangles are also similar. Now, moving down here to our third example, we've got two pairs of sides and we have an angle. The angles are both 80 degrees, so let's check the ratio of the sides. And if you put this in your calculator, these are actually the same. Both of these equal 1.5. And the last one, we have hypotenuse and another side and the right angle. We just check the ratio of the sides. And you can just put this in your calculator. And again, the ratio of sides here is 1.5. So all four pairs of triangles in this example are similar. Now, what you guys can do is go and grab your textbooks, open up to page 419, and just start going from question 4. Thanks, guys.